Write chemical equation first with correct formulas. For example, H2 plus O2, H2O. Now pick the element from extreme left side of equation. In above example, hydrogen is present in extreme left side of equation. Count all hydrogen atoms present left side of arrow. There are 2 hydrogen atoms in total. Now again, count all hydrogen atoms present in right side of arrow. There are also 2 hydrogen atoms in right side of arrow. Hydrogen is looking balanced, but not final till we balance the whole equation. Now we count oxygen atoms from left side of equation. There are 2 oxygen atoms in left side of arrow. Now we again count oxygen atoms from right side of equation. There is only 1 oxygen atom in right side of equation. So, it is unbalanced. Note, we can add coefficients only. Now we add 2 as coefficient to balance oxygen. This 2 will not only multiply oxygen, but also multiply with hydrogen of water molecule. Now, if we recheck, we will find that number of hydrogen is now increased to 4 in right side of equation. Now, we again have to go to the right side of equation to balance hydrogen atoms. If we multiply H2 with 2, we get 2 cross 2 scouse 4 hydrogens in left side. Now again, check the whole equation. Total number of hydrogen atoms in left side are now 4. Total number of hydrogen atoms in right side are now also equals to 4. Now we recheck oxygen atoms in left side of equation, which is 2. We again check oxygen atoms in right side of equation. This 2 is also multiplying with oxygen of water molecule. Now total number of oxygen is also equal to 2. So our equation is balanced. Let me take another reaction. First, write the chemical equation with correct formulas. Now pick the element from extreme left side of equation. In this equation, aluminium is present in extreme left side of equation. Count all aluminium atoms present in left side of arrow. There is only 1 aluminium atom in left side. Now again, count all aluminium atoms present in right side of arrow. There is also 1 aluminium atom in right side of arrow. So aluminium is looking balanced, but not final till we balance the whole equation. Now we count chlorine atoms from left side of equation. There is only 1 chlorine atom in left side because there is 1 chlorine in HCl. Now we again count chlorine atoms in right side of equation. There are 3 chlorine atoms in right side because AlCl3 contains 3 chlorine atoms. So it is unbalanced. Note, we can add coefficients only. Now we add 3 as coefficient before HCl to balance chlorine. This 3 will not only multiply chlorine, but also multiply hydrogen atoms of HCl. Now, if we recheck, we will find that number of hydrogen atoms is now increased to 3 in left side of equation. Now we again count hydrogen atoms. Total hydrogen atoms in left side are now 3. Total hydrogen atoms in right side are 2 because H2 contains 2 hydrogens, so hydrogen is still unbalanced. Now we cannot directly balance 3 and 2 easily. So we multiply the whole HCl by 2 and also multiply AlCl3 by 2. Now chlorine atoms become balanced because right side has 6 chlorine atoms, left side also has 6 chlorine atoms. But now aluminium becomes unbalanced. There are 2 aluminium atoms in right side but only 1 in left side. So we put 2 before aluminium. Now recheck hydrogen atoms. Left side has 6 hydrogen atoms, right side has only 2 hydrogen atoms. Now we add 3 as coefficient before H2. Now again check the whole equation. Total aluminium atoms in left side are 2. Total aluminium atoms in right side are also 2. Total chlorine atoms in left side are 6. Total chlorine atoms in right side are also 6. Total hydrogen atoms in left side are 6. Total hydrogen atoms in right side are also 6. Now look at equation. All atoms are balanced in both sides of equation. So our equation is balanced.